So then, and that is always almost always a very low number. So then, what's actually causing things to be expensive is how you put the atoms into the desired shape.
Yeah, actually, if you don't mind me taking a tiny tangent, I often talk to Jim Keller, who's somebody that worked with you as a friend.
Yeah, Jim was did great work at Tesla.
So I suppose he carries the flame of the same kind of thinking that you're talking about now. And I guess I see that same thing at Tesla and SpaceX. Folks who work there, they kind of learn this way of thinking, and it kind of becomes obvious almost. But anyway, I had he educated me about how cheap it might be to manufacture a Tesla bot. We had an argument. How can you reduce the cost of scale of producing a robot? Because I gotten a chance to interact quite a bit, obviously in the academic circles with humanoid robots, and then Boston Dynamics and stuff like that. And they're very expensive to build. And then Jim kind of schooled me on saying like, okay, like this kind of first principles thinking of how can we get the cost of manufacture down. I suppose you do that. You have done that kind of thinking for Tesla Bot and for all kinds of complex systems that are traditionally seen as complex. And you say, okay, how can we simplify everything down?
Yeah, I mean, I think if you are really good at manufacturing, you can basically at high volume. You can basically make anything for a cost that asymptotically approaches the raw material value of the constituents plus any intellectual property that you need to license.
Right.
Anything.
Right.
But it's hard. It's not like that's a very hard thing to do, but it is possible for anything. Anything in volume can be made, like I said, for a cost that asymptotically approaches its raw material constituents plus intellectual property license rights.